Hello everyone, I'm Zainab CodingWali, currently a proud level 1 batch 3 student at Rahan School Online Academy. So today I'm pleased to welcome Mark Novak. So he's basically an experienced technology professional whose career offers valuable insights into long-term growth, system thinking, and lifelong learning in tech. So hi Mark, how are you?
Oh, I'm doing well. I have some cats that are zooming about, so there might be brief interruptions, but hopefully there's no big deal. They're not going to make a big deal.
Okay, so Mark, to begin our conversation, could you share an overview of your professional journey and how you entered the field of technology?
Okay, basically what happened was is that I grew up. I went to college at the time when computers were more expensive. A lot of times, most people didn't have home computers at the time. That was back in like 1981 when I went to college, and but my second year in college, someone introduced me to computer technology. Actually, my first year in college, someone introduced me. I took a class, introductory to computer technology, and I found that programming back then, programming in the older machines was fun, and I thought it was a professional interest. I basically found that this was one of those fields in which you either the results are easily measurable. You either knew what you were doing and had results, or you didn't. So I liked that. So I went on and got myself a degree in management information systems with a minor in computer science, and went forward from there. I started working. I worked initially for almost 28 years for a large manufacturing company in which I was able to apply, my mainframe computer skills technology on a steady basis. There was always work, always development and support work. There was always something to do with some challenges. And then from there, I went to other companies, including financial companies and pharmaceutical companies, and now a telecommunication company. So I've been able to apply my mainframe skills because even though the mainframe was declared dead or dying in the 80s, it is still active and still a very important part of the industry today. And there's a demand for individuals. So, right now I'm in a tier three support individual in a large telecommunication firm, also supporting the database operations, and I'm fairly happy, and the work is steady.
Okay, that's great. I like it. So, I was curious to know that what are the key responsibilities of managing databases that support large and critical systems?
Well, the importance of these systems is that they is that the users view them as a push button system, but there's always small things that you need to do with those systems. You always, they need to be resized. You need to make sure that everything's running efficiently. Things could go down. There are particular issues. So what happens is that you have to be ready on a support basis, making sure that the technology is there. But more important, a lot of times you have to be active and make sure that what seems to be a minor issue doesn't shut things down, because when databases are shut down, they basically shut down the entire application. So it's one thing for a program to go wrong in which people can't do certain things, but if you ever hear about major outages, a lot of times that's because a database had an issue, or an operating system had an issue, or more common, a database had an issue which shut down an operation of a major company, and that can be very expensive, and you don't want to be famous for that.
Okay, that was a great answer. But I wanted to know, like, in Rahan school, we do coding tasks. So could you give me, like, the meaning of database and, like,
Oh,
what?
okay. Okay. Database. Okay. What happens is that you'll hear about products, and a lot of times you'll hear about large companies like Oracle, and Oracle is one of these companies which manages one of the underlying database products. A database is basically, a set of computer references. So if you are online like on with Amazon, or if you're online with a company's web server and you enter information, chances are they're going to put that information through a primary interface, and then from that primary interface, they are going to have they're going to store that database, that data in a location in which they can access it, somewhere. And that, for retrieval and active going, because what happens is that they will store your information out there, and then they need to be able to retrieve that information. So the next application, a lot of times, either you're putting information, you're sending information in a queue or a file, or you're storing it in a database, and then the next application, like let's say that you've logged on, now you want to buy something. Well, it's going to have your information stored on a secure database in order to get that particular information. If you wanted to buy that product, that the product catalog is going to be stored on a database. A lot of times you take for granted, but if you got millions and millions or even billions of pieces of information out there, like what did you buy a year ago? Or what was the transaction? That's going to be stored in various databases and various tables that will tell computers how to operate. So it is central. So if it can't get to the information, then all the applications shut down. And depending on how big it is, it can be industry wide. Is that a better answer?
Yeah, that's a very good answer. Thank you for um like giving me the answer. It was really great. Okay, so why are mission critical systems so important that making them challenging to manage?
Oh, so what was the question again? My apologies.
Okay, so what are the mission critical systems so important and what makes them challenging to manage?
Okay, well, the mission critical systems that are so important, I can't give you the proprietary names, but there are various products, and what happens is that these products have manuals that will tell us how things are configured, how things are communicated, and the challenge is that a lot of times if you have a screen, the screen that is on the web will send to an interface that is like within like the IMS. And you have to be able to trace those particular items, saying, oh, someone entered information on this screen, it went through this layer, it communicated through the web using this container, it went into this computer went into a screen that used to be an old green screen, and now that green screen is going into a computer, to a program, and then that program is now communicating. So the challenge is with an application is that there can be many layers and things can go wrong in various layers. So the technologies that I'm supporting, there's something called DB2. There's an old database which is really old, but it's still used for a lot of things, and it's actually the heart of the system. It's called IMS, and IMS is a system that is the core of the processing. It has databases, but it's also an environment. And then within IMS, there is also another applications where it can communicate via the IMS layer to an IMS database, a DB2 database, or an Oracle database. So then you have to track from the background, from the front. So you'll have these various products that use various database technologies, and then you have to know what technologies are going, and you have to be able to trace through from there. It's not really the answer you're looking for, but I can't give you proprietary information. I wish I could, but that would get me in trouble.
Okay, I understand. So how do you keep your skills relevant as technology continue to change throughout your career?
Well, that's one of those interesting things. Matter of fact, the company that I work for has got some AI training courses, so we're trying to keep relevant in AI. The technology, even the old technologies like IMS and DB2 and Oracle, those technologies, they go through changes and revisions, so you're constantly educating yourself as to new updates, and then you're reading about the interfaces. So what they're doing is that I know about new technologies like Java. I know about new technologies like, okay, C Sharp is not a new technology, and neither is Java, but you're aware of those programming languages. You're aware of the interfaces, which are constantly changing because you have to know what client is using and understand what are the options when they're upgrading a particular technology. So there's always small education, but recently we have been educated into the underlying uses of AI. They're trying to use AI to understand some of the computer applications. We got millions of lines of assembly language programming on the mainframe, and we have millions of lines of PL1 programming on the mainframe, and not very many people know it. So they're trying to train AI to be able to at least map it out so we can find underlying problems. And that is always a challenge because it requires a lot of human intervention to train an AI model.
Okay, so next, I would like to know that, like, um, is like in your work, so what role does AI play? And I wanted to know, yeah, that's
Okay, what was the question again? I'm sorry.
okay, no problem. I wanted to know that what role does AI play in your like role in your profession?
Okay. Well, AI at the mainframe level is still has a lot to learn. Now, AI has been trained in order to write programs that can do things like in Java and C Sharp and an awful lot of processes that run on the mid-range and microsystems. But in my particular role, we're still training AI in order to understand the assembly language programming and understand the PL1 programming. And the role it's going to play is that it will help us map out that if there's a transaction or an issue that the AI would be able to understand the computer flow enough in which it can narrow it down to the small part of the assembly language program that we need to look at to narrow it down to the transactions because we'll have a map. So something will go wrong and we'll be able to see using the AI where that went wrong and be able to trace it.
Okay, wow, that's great. So, what core skills do you believe every database or system professional should develop early on?
Oh, well, one of the weird things that you might want to develop is that you might want to be able to get yourself used to adding and subtracting in hex because there's a lot of stuff which is within hexadecimal in which everything is in base 16 and then understanding the basic IBM computer sets. You may not necessarily ever write any programs in assembly language programming, but a lot of the more boring technologies like COBOL and PL1 and assembler, you will probably need to know those particular technologies and know what the assembly language instructions are. You may never have to write one of those, but understanding that would give you a good basis for understanding more elaborate things and also understanding and be trained in database technologies. Just basically getting yourself a book of Oracle or DB2 that will teach you the fundamentals about how databases are stored and how databases are managed. Basic understanding of mainframe operating systems. You're already going to be exposed to mid-range operating systems and web systems, but having a deeper understanding of that would give you an appreciation of technology, and that underlying technology understanding would help you through with processes, even if you never really touch a mainframe process.
Okay, I like it. So, finally, what trends or skills do you think young learners should focus on to prepare the future of the tech industry?
Okay. Well, the other skills that you would probably need is that to learn some of the basic programming technologies that are available in the mini computers, on the web, like Java. Also, be able to understand some of the technologies that allow you to handle interfaces. And it's very important because a lot of processing these days will go into things called queues. So you'll hear about technologies like MQ. And MQ is at the heart of just about every transaction processing system. So someone remote in another country might buy something and they will enter credit card information on a cash register, and that would go into a queue, which will go to a processor, maybe a processor in the local country, and then that process can go across literally to the other side of the world in order to process in near real-time transactions. So understanding how MQs work and how queues work, that is a basis for computers talking to each other, doing safe transaction processing, which makes commerce possible, which makes store sales possible, and it makes an awful lot of processes possible that would be, too expensive to be implemented locally. So you will have to, so that would be another technology you would want. Also, just understanding, just getting a basic understanding of communication is good. I mean, having a good, strong basis in communicating in English or, your home language, being able to communicate so you can communicate in plain English to your bosses exactly what is going on. And I'm rambling. Sorry about that.
Oh, no worries. Okay, so you may have seen many phases of technology. So, what role has lifelong learning played in your career?
Um, so what was the question again? I'm sorry.
Okay, my question was that you have seen many phases of technology. So, what role has lifelong learning played in your career?
Oh, well, a lot of times the technologies, even though they might have a different label on them, they might have fancy names. A lot of times the underlying structures look remarkably the same. If someone is in manufacturing and they're working in technology like ABOT, which is the underlying communication technology for SAP, you will look at the ABOT processing, you say, well, that looks an awful lot like COBOL and C put together to me. So learning basic C programming language, learning COBOL programming language, these languages, even though they've been declared obsolete, there's still the underlying coding technology and ideas are still being used in other processes. So just basically being really good at more than one programming language would probably go a long way. And then just basically reading about, the technology challenges of the past, and just reading about what companies have faced when, in changing times. A lot of times those challenges that the first tool that they're going to be going after is addressing their underlying information technology.
Okay, that's great. I like it. So, based on your long career, what lessons have you learned about building reliable and long-lasting systems?
Um, oh, Well, one of the basics that I've learned is that you're not necessarily going to accept the obvious. That you don't want to. That there were times in which there were client server languages that were introduced in the 90s that were declared the future, and you don't want to necessarily latch yourself onto technologies which are associated with just one company. Because if that technology is associated with just one company, chances are it's going to have a very short half-life. So look at technologies and look at companies, information areas that are like industry approved and industry standard. Try to latch onto something which isn't just a fad, just in one company that has a group outside of that company that manages that particular technology. And just learn about that. And then learn about the finances and the underlying structure and politics of the operations of the companies, because that gives you a heads up about what is really the future and what is just an illusion of the future. And information technology, the stuff that lasts long tends to have an outside organization that is across companies that is supporting it and declaring the standards for it, like Java.
Okay, that's great. But I was kind of curious to know that why is it important to manage financial records?
Oh, what is important to manage financial records is that you're going to have to is that you have a configuration in which you have a firewall in which you have interfaces which are going across firewalls and being able to determine exactly and be able to determine how information can be secured. When you are managing financial technology, you are dealing with encryption, you are dealing with in-flight, you are dealing with secured servers. So what you want to do there is that with the finance, you need to go out there and you need to be able to keep the firewalls up. You need to keep the firewalls current. You need to keep the databases secured, and you also need to make sure and have a way to know that the information that is coming in has not been, has not been interfered with in flight, and that there are transactions, that there's ways of declaring that the information that you're getting in and the transactions that you're getting out are are accurate, and you don't want people hacking in and taking millions of dollars out of your financial transactions by spoofing a system or doing the various tools that will allow people to hack in, like code injection. You need to be able to make sure that your systems are up to date and that doesn't happen. Mainframes are actually more secure in keeping track of financial technologies because they are almost impossible to hack into. So it's good to have a mainframe behind in managing your finances using probably a DB2 database and IBM technology. And I have spoken.
Okay. So, in your experience, why it is important for professionals to understand legacy system alongside new technology?
Well, the reason you have to understand legacy systems is that they haven't gone away. And the other thing is that a system has been there for years for a reason. I mean, no one thought back in the 70s that the code that they were writing would still be operational today. So imagine code that is 50 years old that is still running on the mainframe. But the reason it is still working today is because it works well. The reason I understand legacy systems is that they are compiled code running on mainframes, and mainframes can do high band processing much faster than cloud computing for much less money. So a cloud computing system can operate as fast as a legacy system, but it takes 10 times more processing power and an awful lot more overhead. So understanding legacy systems, you're understanding systems which are fast and efficient. And the reason that they're fast and efficient isn't because geniuses designed them. It's because the best legacy systems have survived over time and they're just hard to replace. So you're looking at natural selection. You're looking at the survival of the systems that are the most rigorous. So if you have an old system from the 70s or 60s or 80s out there running on a mainframe, there's a reason why it's still there. So it's a good idea to understand the reasons why it's there and be able to leverage it to as much as possible to keep it going.
Okay, that's great. I look forward to asking you more questions. So, working with critical systems involves high responsibility, you know. So, how do you manage pressure and ensure reliability in your work?
Okay. The other thing that you have to make sure in IT is that you give yourself plenty of sleep, that you give yourself time, you give yourself downtime. The biggest mistake that people do in IT is that they think they can work 60 hours a week, or 24/7 and be ready 24/7 over a year. But what happens is that over time you become less and less effective. So you need to be able to take breaks. You need to be able to have other individuals who are trained in what you are doing so they could take over and you could hand things off to them and then they can hand them back to you. Because in IT work, it is a long-term grind. So being ready and being able to meet those particular challenges basically means that not only do you need to be trained and understand the systems you're supporting, but you also need to be rested and ready.
Okay, that's great. So, for students who are still studying, how can they gain practical real world experience early on?
Oh, a practical real world experience early on. Well, that would be, I would recommend if there was any interning programs that allowed people to look look at some of the basis of mainframe technology, that would be good. The other thing is that an awful lot of back office operations that they are interfacing with particular mainframes. Get involved with companies. If it might be really difficult to get involved with companies that might have that you're looking at that do list technologies like COBOL and DB2 and CICS, or even off of that. Sorry about that. I have to talk to this kitty. That list of COBOL, CICS, IMS technologies. If they are listing technologies like PL1, that those companies are actually doing some mainframe processing in the background, and that way you might be exposed to mainframe. So working for one of those companies or trying to latch on to one of those companies that is there, it might give you a chance to get early exposure to mainframe technologies. And then, there are just some books out there. Unfortunately, there's a lot of software licensing issues, so I'm not sure if it's possible to mess with virtual mainframes virtual mainframes because of the software licensing issues. But some companies are still running it. The problem being is that running a mainframe it costs millions of dollars a year in leasing costs. So whatever company is going to be there, they're going to tend to be bigger companies, or maybe a contracting company associated with one of those companies. I wish I could tell you there was an easy way in. It's just you have to work at it and look for the opportunity.
Okay, if you want to tell me, so you can.
Yeah. Um, I just look for companies that are associated with IBM technology, and look for companies and that would probably lead you into a mainframe role.
Okay, so would you like to tell me that from a personal point of view, which qualities or habits have helped you succeed constantly over the years?
Okay, one of the habits that I've had that has helped me succeed constantly and over the years is just basically being curious about things in general. A lot of times being able to keep your mind, keep your mind fluid. It's a lot of willingness to not just focus on what you know, but focus on other aspects of things. So, just reading a lot of fiction is good. Keeping up with the news is really good, but you need to read stuff every day, because the same part of your brain that is used in IMS technology, that is used in IT technology, is also the part of your brain where you're reading and you're understanding things. So just read, understand, and never take what you know for granted. And that's normal. That will make you a well-rounded person and the type of person that they would want in this particular field.
Okay, that's great. Okay, Mark, so beyond technical skills, what other abilities should students develop to become strong technology professionals?
Okay, you might want to get yourself into some of the areas of sciences that understanding. It's sort of weird, but understanding things like geology, understanding weather systems, understanding some of the systems that they might use IT to understand. So of course, space travel is an obvious thing, but just shipping and transportation, understanding logistics, understanding those particular aspects of the world, because logistics involves shipping, and shipping involves an awful lot of computer processing in the background. There are applications that make sure that a ship is loaded properly at the dock. There are applications that keep track of transactions. So understanding supply chain technology, understanding supply chains, understanding manufacturing at a deeper level, understanding the manufacture of composite parts and exotic materials, understanding mining. So going deep into those particular areas would give you an appreciation of where information technology fills in to make those processes possible and manageable at a large scale.
Oh, that's great. So when facing complex technical problems, how do you usually approach problem solving, and how important is problem solving?
Okay, in problem solving at a mainframe at the mainframe level and the technical level, a lot of times what happens is that you have to use the tools that are available to you. So you'll have a tool like you'll have a tool like a Band-Aid. And so if a program fails in the middle of the night, a lot of times you're going to have a Band-Aid process. This Band-Aid process is going to tell you where it went wrong in a particular program, and then you can narrow that down. And then as part of your skill set is that you can see the basic transaction, you can see the basic data where things went wrong. And when that happens, you end up with a place to start. You go to the particular program that went wrong. You try to figure out if it was a process that happened within that program. Then you say, well, was it some data that went into that program in the middle of the night that will track you to a particular process that will lead you to an online transaction, an online program, an online screen, someone entered data, and then you can figure out if that data was wrong or if something came in from another system. So you start with the basic where it went wrong, and then you can track backwards, looking at the files, looking at the databases, looking at what they call transactions on the queue to try to figure out where that data went from and how it was able to get to that process, whether or not it was a flaw within the program or whether or not it was a situation in which another process sent something unexpected and the program didn't know how to handle it. So starting with the basic where it went wrong and being able to flow backwards through the files, meticulously one at a time. You don't want to jump to a particular location. You want to say it went from here it came from here it came from there. And that normally allows you to narrow down processes really quickly in the middle of the night and then give them a full report the next day.
Okay, that's a very, very, very good answer. So, to conclude our discussion, what message would you like to share with young learners about patience, consistency, and long-term growth in technology?
Well, one of the things that I would say is never accept the obvious. And I think I've already repeated that sometimes there's some technologies that people would declare will be really good. There are people who romanticize putting robots on Mars, but putting a robot on Mars, opens up a lot of questions. So don't romanticize, the technology or dazzle. That I would say focus, if you're going to be a long-term player in IT, focus on the more boring parts of a particular process, focus on that background technology, because a lot of times background technologies are the best option for staying relevant in the long term. They don't change nearly as much. They're not the dazzle, but they're also the technologies that make the difference and that hold true in the long run. And that's true for a reason. So focus on the long-term technologies, do the boring parts of IT.
Okay, that's a very interesting perspective. So, thank you for sharing. Okay, so everyone, this was my second foreigner interview with Mark Novak. Hope you like it. Until then, take care of yourself and bye bye,
All right.
everyone.
It was real good talking to you, and bye-bye.
Bye.